If we're going to talk about how you can use a linked to dataset to query datasets, we should make sure that we're all on the same page when it comes to datasets. So let's do a quick review of datasets. The dataset is an in-memory cache of data. So you bring data down from a dataset, and the dataset is in memory. And therefore, it's a disconnected model. You connect to the data source, bring data down, it's in a dataset, and then you disconnect. And the dataset is a relational view of data. So it contains tables, columns, rows, constraints, views, relations. You can sort of think of it as a mini relational database in memory, if you will. There are two types of datasets, typed and untyped. A typed dataset is based on an XML schema, and therefore Visual Studio knows what the structure of the dataset is. An untyped dataset still has tables and columns and rows, but because there's no schema, Visual Studio doesn't necessarily know the structure of the dataset. And so the benefit of typed datasets is that they're strongly typed. If you want to refer to the product name column in the products table, you can say products.productName, and you'll see product name in IntelliSense. This makes it easier to type code, and there's no risk of misspelling the column name. In an untyped dataset, you'd say products and then in parentheses and then in quotes the name of the column. And if you misspell the name of the column, that's a runtime error, not a design time error. Tables in a dataset are represented by the data table class, and rows are represented by the data row class. Well, how do you work with data in a dataset? You've got a couple choices. You can use a data adapter to bring data down, and there are two types of data adapters. The SQL data adapter is optimized to work with SQL Server, and that's all it works with, and the OLADB data adapter works with any data source. Or you can use a table adapter. The table adapter extends the functionality of the data adapter. And one of the biggest benefits to it is it can contain multiple queries. So you might have a data adapter with a SQL statement that says bring down all of the customers in the customers table. A data adapter might have a SQL statement to bring down all of the customers, but it might also have a SQL statement to bring down only the customers for a particular customer ID or the customers in a particular country. Both the data adapter and the table adapter have a fill method that you can use to retrieve data from the data source and fill a data table. You then make any changes you want in the data set, that's all in memory, and then to save the changes, you can call the update method of either the data adapter or the table adapter, and that will write the changes back to the data source. So that's a quick, high-level review of the data set. So what does linked to dataset offer? And that's a good question because there's a lot of power in datasets. We've been building database applications based on ADO.NET and datasets for quite some time. What does linked to dataset bring to us? Well, it brings an easier way to query the data in a dataset. And because it's linked to dataset, you can query the data in the dataset using the familiar LINQ query syntax. Linked to dataset works both with untyped and typed datasets. It supports updating data, it supports data binding. And because the dataset's in memory, LINQ queries just get translated into .NET Intermediate language. So there's no need to go to the database server. You'll typically use the data adapter or the table adapter to bring the data down, and then once that data is in the dataset, you can query it using LINQ. That doesn't require a round trip to the database server because the information's already in the dataset. So to query with linked to dataset, first you need to retrieve data and populate data tables in the dataset. And the data doesn't have to come from a database. It can come from a database, but it can also come from XML, from objects. And there are a number of ways that you can fill the data tables. You can do it in code. You can use a LINQ to XML query. You can use a data adapter, a table adapter. It really doesn't matter as far as linked to dataset is concerned, because once you have data in the dataset, then you can use LINQ queries to query the data tables. Now, linked to dataset uses the familiar LINQ syntax, but there are some differences that we need to talk about. First, let's talk about querying in an untyped dataset. The data table class does not implement IEnumerable. So that means you can't just query directly on a data table. What you have to do is use the data table's asEnumerable extension method. And then to talk to fields, you have to use a generic field accessor to refer to columns in the data table. So what does that look like in a query? So here's a query to bring back the product name for all products that cost more than $25. So my query is from product in products.asEnumerable. I can't say from product in products. I have to say from product in products asEnumerable. And then in the where, product.field, then in brackets decimal because unit price is a decimal type, and then in parentheses and quotes, the column unit price greater than 25, select new, and then again to refer to the product name, product.field of string, and then in parentheses and quotes, product name. I don't get IntelliSense here. I have to use the generic field accessor and the asEnumerable. So the basics of this query are familiar, but then I have to add the asEnumerable and the dot field. Now when I query in typed datasets, life is much easier because typed data tables now inherit from the generic typed table base class, which does implement IEnumerable. So I don't need the asEnumerable or the generic field accessor. And I say they now inherit because in Visual Studio 2005, typed data tables were just regular data tables, which does not implement IEnumerable. But now, in Visual Studio 2008, or more specifically the .NET Framework 3.5, typed data tables inherit from typed table base. So now my queries against typed datasets use the familiar LINQ syntax. So here's the same query we just ran, but now it looks much more like the LINQ queries we've written before. From product in products, where product.unitPrice is greater than 25, select new product.product name. So let's go see a demo of querying various types of data using LINQ to dataset. I have the LINQ to dataset solution open, and this solution contains two projects. LINQ to dataset is a console application, and we're going to use that to look at querying with LINQ to dataset. And Windows application is a Windows Forms application, and we'll use that to show data binding. So I'm going to set this to be the startup project because I want to work with this one first. In this project, LINQ to dataset, I have a dataset that comes from the Northwind database. Let's take a quick look at that. I've got customers, orders, order details, products, and categories. And I created this in the usual way by going to Add New Data Source, saying I want to connect directly to a database, connecting to the Northwind database on SQL Server, and then selecting those tables. Okay. And we're going to use that very shortly. Well, let's run this and do some LINQ to dataset queries. Well, the information in a dataset can come from a variety of places. And we're going to see examples of using the file system, using an XML file, and then using the Northwind database. Let's start off with the file system. So I want to create a data table filled with information about files in a particular folder. So I don't literally need to create a data set first, particularly since I'm just using one data table. So I'm going to create a new data table called Files, and then I'm going to add two columns to it. One named File Name, which is a string, and one named Size, which is a 64-bit integer. Then I'm going to create a variable data row, which is an instance of the data row class. Data tables are comprised of data rows. I've got my data table. I now need to fill it with data. Where's that data coming from? I'm going to use an instance of directory info, which is in system.io, and point it to the root directory on C. And then I'm going to call directoryinfo.getFiles to get a collection of files in C:\\. And then for every one of those, I'm going to create a new row in the files table, and I'm going to set the file name column to the name of the file and the size column to the length, and then add that row to the files table. So let's run that down to here. Now files is a data table. It's got columns. It has rows. And it has 9 rows. There we go. I can also use the dataset visualizer, which I probably should have done in the first place. And I can see the contents of this table. Now that I have a table, I'm ready to query. I want to query and find large files, large defined as any file greater than 100,000 bytes. So my query is from file in files.asEnumerable, where the size is greater than 100,000. And to refer to the size, I have to say file, which is the table, .field, and then in brackets, int64, and then in parentheses and quotes, the name of the column size. So where size is greater than 100,000, select the file name and the size, once again using the field accessor. So now I run that query, and now I have my query results, and for each file in those results, I'm going to display the file name and the size. So let's do that and run down to here. So here are the large files, the files over 100K. For the next query, I want to find the sys files. So my query is from file in files.asEnumerable, where file.field, which is a string, and the field is file name, dot contains dot sys. So bring down those results and display all the sys files in C:\\. So here what I did is I created a data table. I filled the data table by hand with information from the file system, and then I can write LINQ to dataset queries. Let's see an example where the data comes from an XML file. So first I'm going to create a data table, and it's going to contain information on products. So I'm going to add a column for product name, quantity per unit, unit price, etc. Now I want to fill this table with information from an XML file. Let's take a look at that XML file. It's products.xml. And there is a products element. Within that, there are product elements. And within the product element, product name, quantity per unit, unit price, etc. So I want this data into a data table. Well, the first time I did this, I used the XML reader to read through that XML, get the values of the various elements, and I filled out the data table. And after that, I said, well, why am I writing all that code? Why don't I just use LINQ to XML? So that's what I'm doing here. The variable XML file represents the XML file, and I get that by calling xDocument.load. And then I write a LINQ to XML query. LINQ to XML is covered elsewhere, so I'm not going to do an in-depth review of that, obviously. But here's a simple LINQ to XML query. From product in XML file.descendants product. So basically go into this XML file and bring me back all of these, the product elements. And then select product.element, product name.value says, get me this. And then the same thing for quantity per unit, unit price. So go in here and for every product element, get me the value of product name, get me the value of quantity per unit, etc. And so that XML brings back this query, products from XML. Now I'm going to loop through that, and for every product in products from XML, now I'm going to add a row to the data table. The data table is products, and I'm going to use the load data row method. And I pass an array of objects, and all I need to do is fill that out with the product name, the quantity per unit, unit price converted to decimal, units in stock, units on order. So I create a new object, and in the constructor I pass in the information, and then I can create a new row in the data table from that. In the next section, when we look at data binding, we'll see LINQ to dataset provides a copy to data table method, which gives you the ability to copy the results of a query to a data table. We can't use that here because that only works if your query returns a collection of data rows. And a query from XML does not. They're just objects. So we have to fill out the data table by hand. Okay, so let's run down to here. And we now have this data table products, which is a data table containing the information from the XML file. Now I know we're doing link to dataset here, but I just have to say this is really cool. Link to XML. Okay, back to link to dataset, which is also very cool. So let's query this XML. What products cost more than $25? So the query is expensive products from product in products.asEnumerable, where the price is greater than 25, ordered by the price descending, bring back the product name and the unit price. So the structure of the query is very simple. We just have to do a fair amount of additional coding, the asEnumerable, the field, decimal, the unit price, in parentheses and quotes. But once we do that, we have a query, and we can loop through that query, and for each product, display the name and the price. So here are the inexpensive products. Let's do one more query. What products are low in stock? From product in products.asEnumerable. Let's check units in stock less than 10, bring back the product name, the units in stock, and the units on order. So here they are. So again, you can see that when you write a query using LINQ to entities, it's the familiar LINQ syntax. But because so far we've looked at information that comes from a file system and from XML, now let's look at a data set where the data actually comes from a database. So I'm now going to create a data set because it's going to contain multiple tables. And I'm going to use a SQL data adapter. And the SQL data adapter contains a select statement and a connection string. So the connection string is to the Northwind database on SQL Express. And I want to have a products table and a categories table in here. So I'll create products data adapter, specify the connection string and the SQL statement, select star from products. Then I'm going to call the fill method of that data adapter, and that will populate the products table in my data set with the results of that query. And then I'm going to do the same thing for categories. I'll create the categories data adapter and specify that when I run the fill on that, I'm going to bring down the information from the categories table on the Northwind database and put it in the categories table in my data set. Now because this is an untyped data set, to reference a table, I'd have to say dataset.tables and then specify the name of the table. I don't want to do that over and over again, so I'm just going to create two variables here, products and categories, as data tables, and they'll be shorthand to the products in the categories table. So now products is a data table with products information. Categories is a data table with the categories. Now I can query these. So let's get the inexpensive products from product in products as enumerable, where product.field, decimal unit price less than 10, etc. So if you looked at this query and I asked you, here's a link to dataset query. Where'd the data come from in the first place? Your correct answer is, I don't know. It's in the data set. It doesn't matter. I'm going into the products table in this data set, and I'm going to look at the unit price, and if it's less than 10, I'm going to bring back the product name and the unit price. Where that data came from, an XML file, a database, doesn't matter for the purposes of our querying. Okay, so let's display the inexpensive products. Let's go down to here. Run to cursor. Okay, here are the inexpensive products. And then we'll do one more query. I want to get not only the name of the product, but also its category, if it costs less than $10. So this is going to be a join between products and categories based on category ID, where the unit price is less than 10, then bring back the product name, the category name, and the price. So now when I run this, Here's the product name and the category and the price. So link to dataset, querying untyped datasets. These are the types of queries you write. Well, let's see how it differs if I use a typed dataset. Now, I showed you the typed dataset before. It's the Northwind dataset. And again, in that Northwind dataset, I have tables, and every table has a table adapter. And the table adapter is generated code. It extends the data adapter. It has the connection built in, and it can have multiple queries. So the basic query for a customer's table adapter is in the select command, bring back everything from the customer's table. This has the connection built in. It has an update command to send information back, an insert command, and a delete command. And every table in the dataset has an associated table adapter. And then the fill method is going to run the select statement, bring back the customers. So in the top of this, I've defined variables that reference the data tables and the table adapters. So this variable customers is a new instance of Northwind dataset.customers data table. This is a strongly typed data table. And customers table adapter represents that customers table adapter we just looked at, which is in Northwind dataset table adapters. So I can get an instance to Northwind dataset table adapters.customers table adapter, and that is how I work with the customers table adapter in code. Then I have similar variables for each data table and each table adapter. And then, if we go back to query typed dataset, I'm going to call the fill method of the products table adapter and the fill method of the categories table adapter. And now this products table is filled in with products, and this categories table in the Northwind dataset is filled with categories. And now I can query on these. Because I'm working with a typed dataset, I don't need as enumerable, I don't need the generic field accessor. Now I can use the standard LINQ query syntax. From products in products, where product.unitPrice is less than 10, select product.productName and product.unitPrice. And of course, because this is a strongly typed dataset, when I type product dot, I get IntelliSense, and it shows me the columns in the product table. Okay, so let's run this query and bring back the inexpensive products. Let's run down to here. Here they are. Same query, exact same results, much easier to write. Here's the second version where I do the join categories to products based on the category ID where unit price less than 10. So again, same query, same results. But when I query based on a typed data set, I don't need the as enumerable, I don't need the field accessor. The code's much easier to write. So when I query on a typed data set, I don't need the as enumerable, I don't need the generic field accessor. The query is much easier to read and to write. Once you have data in a data set, you'll want an easy way to work with subsets of the data. So you may want to filter. Maybe you want to bring down from the database all of the products, but then work with products in a particular category. Or maybe you'll bring down all of the orders for a customer, but at a certain point in time, you only want to work with the orders placed in a particular year. You want to do sorting. You've brought down products, now you want to sort them by price, or by units in stock, or you want to sort customers by city. Maybe you want to find a specific product or a specific order. So the idea is you have this data in the data set, and now you want to filter and sort and find working with that data. And there are two ways you can do this. You can use a query. You can also use a data view. LINQ to Dataset supports data views. It provides the AsDataView method. So you can create a data view from a linked to dataset query if that query returns data rows. And a data view represents a view of a data table. And again, you can use it for sorting, filtering, searching, as well as editing and navigation. If you want to filter, you can set the row filter property of the data view. To sort, you can use the sort property, and to find, you can use the find property. So let's go see how we can use data views with linked to dataset. So let's look at example E, which is filtering with datasets. So I'm continuing to use the strongly typed Northwind dataset. And I'm going to call the fill method of the products table adapter and fill the products table in that dataset. So again, products is a data table containing the list of products. So now what I want to do is create a query on that. I'm going to call it all products, and I'm going to get every single product from that table. So now this query represents all of the products. Now what I want to do is create a data view from that. So I'll call the asDataView method of that query, and now products data view is a data view. Now it's a data view, it's basically a view into the table. So by default, this data view is going to show all of the products. Now what I want to do is just see products that cost more than $50. So I'm going to set the row filter property of that data view to unit price greater than or equal to 50. And then I'm going to loop through everything in that view. The rows in a data table are data rows. The rows in a data view are data row view. So for each row in the view, I want to get the product name and the unit price. What I'm going to do is get the row that data row view is based on, cast it to products row, and now product row represents a strongly typed instance of the product row representing and pointing to the row, the first row in the view. So let's display this. And here's a list of products that cost at least $50. So again, what I did was I already brought down the data from the database. I created a query that, for starters, retrieved all of those products. And now what I'm doing is creating a view so that I can filter the query results. I'm not literally filtering the products in the database. I'm not filtering the products in the table. I'm filtering the view of the products in the table. Now I'm going to change the filter to units in stock less than 10. And once again, loop through all of the rows that the view is displaying. And here are the products that have less than 10 units in stock. Okay, so just to be clear, and forgive me if I'm repeating the same thing over and over again, I bring down all of the products from the database. I create a query that says by default, let's look at all of the products. And then I create a view into that query, which is really a view into the products in that products table. And then I can look at particular products by setting the row filter. Let's look at sorting. So again, I'm going to bring down all of the products, and the products table contains every product. Now I'm going to create a query to just bring me beverages. So the query is called beverages from product in products, where the category ID is equal to 1, select product. So beverages is going to contain, expanding the results will enumerate, yes, I want to see the results. Here we go. So here's a beverage. Here's another beverage. And here's a beverage. So beverages is my query results. We started off with all of the products. We queried to just get the beverages. Now I'm going to create a view, beverages data view, by calling the asDataView method of that query. And now I want to sort by unit price. So I set the sort property of the data view to unit price. And now I'm going to loop through everything that is in the query, all of the beverages, and sort them by price. Now I'm going to sort by units on order in descending order. And there are the beverages sorted by units on order. So again, my data table has all of the products. I create a query on that, and now I can work with the results in that query by creating a view, and then I can sort those query results in different ways. And this is way more efficient than running this query over and over again. Sure, I could have created this query and said order by unit price. And then, when I wanted to order by units on order, rerun the query. But I don't need to do that. I create the data view, and I can do the sorting and the filtering as well on the view. Okay, one last example of finding. I'm going to bring down all of the orders. Then I'm going to create a query for orders placed by Alfred's Fuderkist, customer ID ALFKey, and then create a data view on that. Now I want to find order 10643. Again, I know that that is already in the data set because I know this is an order that ALFKey placed. So rather than run another query, I just use the find method of the data view, and the data view uses an index, so this is fairly quick. And I find out that this is row 0. So I'm then going to go into the data view and get row 0 and cast that to a strongly typed instance of orders row so that I can display the order date, the required date, and the shipped date. So what we've seen here is that using the data view makes it really easy for me to find individual records, to filter, to sort based on the results of a query. So again, rather than run the query over and over again, I run a query to get my basic set of data, and then I can use the data view to filter, sort, and find.